Basic concepts, pixel or bitmap. We said your digital image is represented by a grid, which is an array of square picture elements known as a pixel. This pixel, they reveal the smallest details about an image, a digital image. And the pixel corresponds to a numerical value. That is a numerical value corresponding to a graphical object. If you pick a screen, for instance, which is rectangular like your computer screen, it is divided into some sizes made up of dots. And so you may have a screen that is 640 by 480. It means on the row side, you have 480. On the column side, you have 640 lines made up of dots. And so when you multiply them together, you get 300,000 dots that fills up that particular screen. And these dots are used to show up the image. If you now have an 800 by 600 screen, it's capable of displaying 480,000 pixels, as the case may be. So digitization refers to the process of translating maybe a piece of information like text, images, sound, recording or video into binary digits. You all know that every information that enters into the computer must be translated into binary digits. And this binary digit is from there we get the contraction of the word bits. So even when you type a number into the computer, it gets converted to binary digits, which in this case refers to the machine language of the computer. If you enter a picture into the computer, it also gets converted into binary digits. And so these pictures made up of the pixels are also converted into binary digits. If it is sound that you are sending into the computer or video, it still gets converted to binary digits. So this bit, which stands for binary digit, is an electrical pulse or signal that represents the state at which it can be in a given moment of time. Usually, this electrical pulse representing the behavior of the circuit of the computer normally experiences two states. It's either on or off, which in this case corresponds to 0 or 1. On or off, when the circuit lights are on, you use it to represent 1. When they are off, you use it to represent 0. So words and images are represented in bits or bytes, where a byte is a collection of 8 bits, which is roughly equivalent to 1 character. So with 8 bits, which is 1 character, there are 2 raised to power 8, sorry, not 28, 2 raised to power 8, which is equals to 256 possible combinations of zeros and 1. And so, digitization, you have 1, which 1 in binary, which is 2 raised to the power of 0. In decimal, it is 1. In hexadecimal base 16, it is 1. 10 in binary is the same thing as 2 in decimal, which is 2 raised to the power of 1, 2. 100 in binary is 2 raised to the power of 2, which is 4 in decimal and 4 in hexadecimal. 1000 in binary is 8 in decimal and 8 in hexadecimal. 10,000 in binary is 16 in decimal and 10 in hexadecimal. 100,000 in binary is 32 decimal, 20 hexadecimal. Then 1 million in binary is 64 decimal, 40 hexadecimal. And then you now have 10 million binary in hexadecimal. You now have 100 million in binary, 256 in decimal, and 100 in hexadecimal. So this table on the right tells us the equivalent binary and decimal, binary hexadecimal and decimal digits from 1 in decimal to 15 in decimal. So 15 in decimal means F in hexadecimal and 111 in binary. That is is measured in the number of bits used to represent each pixel. So if the bit is so much, it means the depth will be much. If it is not much, it means the depth will be a little bit shallow. 1 bit black and white image with no gray, also called bitmap image, is represented with value 0 black, value 1 white. That means once you don't have a black in the image, then the corresponding color is white, which is the opposite, we show. And when white is 0, black is 1, then it means black will show. That is what the image means. 4 bit can represent 16 colors used in low resolution screen. Value 00 black, value 01 gray. That means black and white mixed together. Value 10 light gray, value 11 white. So 8 bit gray, 256 gray levels. Image contains only brightness, intensity data without color information. So you can see the 4 bit images here: 0000, 0001, 0010, up to 1000, and so on. Use it to represent different images. So inside the computer, you will not see black or white, red or blue, but rather you see 0101 in case of blue. 8 bit can have 256 colors, and the 256 color images are often known as index color images. The values are actually indexes to a table of many more different colors. For example, color 3 is mapped to 210. That is how it's represented. Color 3, 200, 1010. So this is 3, 200, 1010. That is, the 200 will tell you the row, the color, the height on the screen that is used in representing it. Then 16-bit can have 65536 colors, also known as high color in Windows. The 16 bits are divided into 5 bits for red, 6 for green, and 5 for blue. 24 bits 224 will give you 16.7 million colors. Each byte is used to represent the intensity of a primary color, red, green, and blue. Each color can have 256 different levels. So for this one, you have color, red, 255, then green is 0, blue is 0, because there are 3 primary colors, red, green, and blue. And any other color you are going to generate must come from these 3 primary colors, how you mix them. Green is, you don't have any red, you have the full complement, 255, and you don't have anything for blue. It is green. Same thing is blue, 00, 255. But when you now come to yellow, yellow is an equal mixture of red and green. When you mix them together, you get yellow. That means you mix 255 of red, 255 of green, you get your yellow. Magenta is a mixture of red and blue. When you mix the full complement of red and blue, you get magenta. 255 red, 255 blue. On your 24-bit color mode, then for cyan, you don't have anything red. Your green and blue mixed together will give you cyan. So 255, 255. Light gray means half of the red, half of the green, half of the blue, you get light green. And then the funny thing is that when the 3 primary colors are mixed together in their full complement, you get white. 255, 255, 255. And when these 3 colors are absent totally, you get black. And that is why on your computer screen, when none of this color is present at all, the computer screen goes black. You don't see anything being displayed. So that is the effect of these particular colors. Then resolution. Resolution measures how much detail an image can have, like we have mentioned before. And there are several resolutions relating to images, some of which are the following: One, you have image resolution, which is the number of pixels in an image. So 193 times 45, 145 will give you 27,985 pixels. 3088 times 2320 will give you 7.16 million, 16 million pixels. That is one, image resolution, the number of pixels you have making up an image. Then you also have display resolution, which is monitor resolution, refers to the number of dots per inch on a monitor. Windows system usually have 96 dots per inch resolution of Windows system. High resolution video adapters or monitors support 120 dots per inch. For example, a 288 times 216 image displayed on a monitor with 96 dots per inch will be 3 inch by 2 1/4 inch. That is how the image will be presented. Then the third resolution is output resolution, which refers to the number of dots per inch on a hard copy output device. We are referring to the printer now. Many printers have 300 dots per inch or 600 dots per inch resolution. And we also say that high quality image setups can print at a range of 1200 dots per inch and 2400 dots per inch or higher. Then let's look at the different sources of digital images that we acquire. There are many sources from which we can acquire or get or create digital images. Among them, we have some drawing or painting programs that may come with our computer or that we buy. Here, the drawing or painting programs will allow you to make an image from scratch with the paint program. And the good program will allow you to choose the depth, the resolution, and size. So for example, if you pick CorelDRAW, it could help you maybe choose the depth of your image, the resolution, and the size, and you are able to now draw that image from scratch. We also have clip art packages. If you go to Microsoft Word, you will see clip art, which are just some templates that are put in place you can use. You can grab an image of a screen. The depth, resolution, and size is determined by the screen. 3, we have digital camera and camcorder. They capture an image from a digital camera or camcorder and store them inside your computer. The depth, resolution, and size are determined by the camera or the camcorder. So the camera resolution is very high. It means that whatever you are capturing will have a higher resolution. Popular depth is 24 bits. Commonly used resolution is 320 by 240, 640 by 480, and 800 by 600. Then number 4, we can also get images from scanners and digitizer. Here you can scan or print a photograph using a scanner and then select from a range of different depths and resolutions. The choice will be determined by the type of the original you acquire. If the original is faint, you are not expecting the scanner to perform much magic. If the original has high quality, it means the scanner will be able to capture it as much as possible and represent it in near perfect condition. If the resolution of the scanner is very high, it means when it acquires an image of high quality, it will also do its best to represent it in the highest quality possible. Then number 5, we can synthesize an image from numerical data. For example, MATLAB software. And then number 6, we can also get image from stock photograph agencies. Some agencies that have snapped some photographs. They may put them online, maybe for you to acquire. You can buy them or you can collect them and then keep them. So you can acquire images from these sources. Then we go to vector graphics. In mathematics and scientific applications, images are seen as vector objects or graphics. Vectors have much to do with lines. lines like that. And so when you get maybe a text on your screen, those ones are vector images. The text you see on your screen are vectors. So even when you expand them so much, their quality still remains the same. So for vector images, they could be represented by such attributes as size, color, and spatial location, dimension, rather than pixels. Doesn't have anything to do with pixel, but it could be represented by size, color, and spatial location. This is an abstract representation of a two-dimensional or three-dimensional scene. A vector graphic file contains graphic primitives. For example, we have rectangles. That is when you call them graphic primitives. It means predetermined shapes that you can acquire your images from. It could be in the form of rectangles, circles, or lines. And there are many languages for describing vector graphics, some of which are PostScript, developed by Adobe as a page description language. We also have virtual reality markup language. It's used for describing a scene in the virtual world. Then three, we have scalable vector graphics, used for describing two-dimensional graphics in XML. It allows three types of graphic objects, like your vector graphic shapes, images, and text. Then the other one is bitmap graphic. That one has to do with, they call it raster graphic. And in this case, you are using dots to represent your image. So when you blow up your image, the tendency is that you may not see it clearly, okay, for bitmap. But when you blow up your vector graphic image, the quality still remains the same. It's not affected. So for instance, if you pick a text now, for instance, like A, maybe the point there, the size there is 12 points, you increase it to 72 points, it becomes thicker and finer. Bigger, thicker, and finer. But when you pick your old photograph you have at home, your passport photograph, blow it up and make it look very big, the quality will be lost. So for comparison factor, bitmap and vector graphic, in terms of processing, a bitmap image is easier to render. Displaying a vector graphic usually involves a large amount of processing. Then in terms of attributes, a bitmap contains an exact pixel by pixel value of an image, and they are bound to the individual pixels that describes them. A vector graphic contains mathematical descriptions of objects. Vectors are bound to mathematical formulas that describe them. Then in terms of resolution, a bitmap file is fixed in resolution. So changing size means losing information. So when you change the size, make it bigger, you lose much information. And they tend to fall apart when you make them bigger. A vector graphic is resolution independent. Changing the size does not really affect them, and they tend not to be as detailed as bitmaps. Memory usage, the file size of a bitmap is completely determined by the image resolution and its depth, while the file size of a vector graphic depends on the number of graphic elements it contains. They are smaller in file size. Smaller in file size. And that takes us to the next topic, color coding scheme. So the choice of appropriate color combination you can use in multimedia presentations can be cloudy. When you say cloudy and cumbersome at times, it means it could be confusing at times. And this is due to the fact that making careful choice of color involves technical and subjective competencies. And sometimes it may also have to do much with your experience. We need to understand the technical compositions of color and how humans can perceive them. Color coding scheme. Color, you already know more about them. So when you think about the color, you start looking at the rainbow. the 7 colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. You start looking at them, almost all colors you are going to think about can emanate from these 7 colors. But in our primary school, we had 3 primary colors, which were red, red, yellow, and blue. In the computer, the 3 primary colors are different. They are red, green, and blue. Different from what you learned in primary school. So that of the computer, red, green, and blue, you mix them in different proportion to get any other color you are going to look for on Earth. So the color coding scheme is the frequency of wavelength of a light wave within the narrow band of the electromagnetic spectrum. Electromagnetic spectrum is the range with which our eyes can comprehend electromagnetic waves, and it ranges from 380 to 760 nanometer. It means anything below 380 and anything above 760 nanometer, our eyes cannot see them. It means we are also restricted in terms of what we see. There are many things we cannot see because of the limitation of our eyes, what it can respond to and what it cannot respond to. So its perception is humans' physiological activities, and it involves choosing the right color or color combination on trial basis or on aesthetic judgment. In true color, each pixel represents some color shades. In true color, each pixel represents some color shades. So let's look at the color scheme. The simplest one is RGB. RGB color code is the most widely used color model in computer graphics and websites. The R stands for red, the G stands for green, and the B stands for blue. RGB is an additive color coding scheme in which varying amount of the 3 primary colors, red, green, and blue, are added to black to produce new colors. Imagine 3 light sources of the primary colors shining on the black surface. Different secondary colors can be produced by varying the intensity of the light on the black surface, as illustrated in this following diagram. This is blue, this is red, this is green. And you are shining these 3 lights on the black surface. If these 3 lights are shining together in equal proportion, you will end up getting white. If some proportion of red, equal proportion of red, equal proportion of green are shown together, you get yellow. Equal proportion of red and blue shown together, you get magenta. Equal proportion of green and blue shown together, you get cyan. If none of these lights are shining at all, your surface will still remain black. So that is how the color scheme operates. RGB is used by all the display monitors, your cameras, and so on. They are used in showing images on the screen. So this is the most popular and widely used color coding scheme, RGB, red, green, and blue. RGB can be expressed in decimal.